Hello viewers, in today's class we are going to discuss one important definite integral involving greatest integer function, right? So here we have to evaluate this integral from 0 to 1 tan inverse, and we have greatest integer 1 plus x square, right? So let us start. So here let us first call this integral as I, right? Now here what we will do, will make use of the method of substitution, and we'll put t is equal to 1 plus x square, right? So when t is equal to 1 plus x square, then x square is equal to t minus 1, and x is square root of t minus 1, right? And we'll also change the limits. So here x varies from 0 to 1. So when x is 0, then t is 1 plus 0 square, that is 1 plus 0, that is 1. And when x is 1, then t is 1 plus 1 square, that is 1 plus 1, that is 2, right? Okay, so now what we have done here, we have substituted t is equal to 1 plus x square, and then we have changed the limits accordingly, right? And now dx over dt is equal to the derivative of square root of t minus 1, and this is 1 over 2 square root of t minus 1, right? So therefore dx is equal to dt over 2 times square root of t minus 1, right? So we have these things, and now we can write our original integral as I is equal to 1 to 2, right? So now t varies from 1 to 2, and we have tan inverse, and here we have greatest integer t, because 1 plus x square is equal to t, right? And for dx we have dt over square root, here we have 2 and here we have t minus 1, right? Now viewers, here we see that the value of t varies from t is equal to 1 to t is equal to 2, right? So when t lies between 1 and 2, then obviously the value of greatest integer t is equal to 1, right? Because from the definition of greatest integer, we know that this t represents greatest integer less than or equal to 1, right? So for example, if we take, say, t is equal to 1.5, now 1.5 lies between 1 and 2, so therefore the value of greatest integer 1.5 is equal to 1, right? So now when t lies between 1 and 2, then the value of greatest integer t is equal to 1, and so our integral I becomes 1 to 2, and we have tan inverse 1, right? Because the value of greatest integer t is equal to 1, and here we have dt over 2 times square root of t minus 1, right? And from trigonometry we know that tan inverse 1 is equal to pi over 4. So now we can write 1 to 2, and here we have pi over 4 dt over 2 times square root of t minus 1, and this can be written as pi over 8, and integral from 1 to 2 dt over square root of t minus 1, right? Now this integral I can be written as pi over 8, and we have the integral from 1 to 2 t minus 1 raised to minus half dt, right? Now here again we can make use of the method of substitution, and we can take y is equal to t minus 1, so dy is equal to dt, and when t is 1, then y is 0, and when t is 2, y is 2 minus 1, 1, right? So now this integral I becomes pi over 8, and we have 0 to 1, because now we are changing the variable t to y, and here we have y raised to minus half and dy, right? And we know that the integral of y raised to minus half is y raised to minus half plus 1 over minus half plus 1, 0 to 1, and we have pi over 8, and 1 minus half is half, so we have square root of y over half, and the limits of integration are from 0 to 1, right? Now this is these two get cancelled, so we have here 4, so this is pi over 4, and we have square root of y 0 to 1, and if we substitute the limits, so we have square root of 1 minus square root of 0, and this is pi over 4, square root of 1 is 1, and here we have 0, so this is pi over 4, right? So viewers, the value of this given integral is equal to pi over 4.